alternate. Two events are occurring alternatively, they cannot occur simultaneously. So what's the first formula? The first formula says E1, event 1 or event 2 is equal to probability of event 1 plus probability of event 2. Okay, this is the case of OR. Another special case is there that E1 plus E2 minus probability of common. Now, why we need to subtract the common? Because common will be counted twice.
Yeah, sir. Yeah, I see it.
It will be
Okay.
counted twice. So it will be counted twice. And the logic is there that if suppose in a class there are 30 students in a class, suppose 15 are taking physics and 20 are taking chemistry. So there are some people who are taking both subjects. In that case, the total is exceeding 30. So you need to subtract the total, the common once. You have to copy this now.
Okay, sure. Just give me a minute.
This is called the explosive case.
Yeah, I noted it down, sir. Yes.
Now
Yes, sir, I wrote it.
look at this example. You can see it orally. This is a probability. Event is 1 till 20. Even numbers are given. Even numbers I have found. Odd numbers I have listed. This is a set language. And prime numbers I have listed. Now you have to find this number 1, 2, and 3 orally.
Okay, sir. Probability of even. Second. So, sir, total numbers are. Sir, probability being even is 1 by 2 because 10 over 20 and then 1 by 2. And then for prime, yes, it's fine, right? And then prime 1. And probability of being prime is 2 by 5, like 8 by 20. And then when you simplify it, it's going to be 2 by 5. And then for even or prime. So even or prime, 1 sec. There would be one common prime number as well. 1 second. Let me just see. So this is a bit. Okay. So I'm getting 17 over 20. Like, sir, I use the second formula like 1 by 2 plus 2 by 5 minus 1 by 20 because that's the common, right? Yeah, okay, okay. Then I get 17 over 20.
Acha. So 1 upon 2 plus 2 by 5 minus 1 upon 20.
Yeah, we get 17 over 20 as the final answer.
17 upon 20. Now, our next concept, sum of all probabilities is equal to 1.
Yeah.
Sum
Yes,
of
sir.
all probabilities is equal to 1. So copy this famous rule.
Okay, just a
Under
second, sir.
one title, under one heading, all the breakup, all the outcomes will be summed to 1.
Yeah, exactly, sir. Yes, sir, I wrote it.
Now we know well about tree diagram, and tree diagrams are part of our syllabus since long time. And for example, Johnny has a 4.4 chance of scoring from a free kick and 0.7 chance of scoring from a penalty. Now free kick and score comes like this. Penalty comes after that. Then you make a connection with that. You must remember that on one single set of branch, the sum is always 1. On one single set of branch, the total is always 1. And we remember that when we talk about the combined score, you always multiply. And then when you make a combined work, you multiply. And if it's a choice, then the total will be added. Acha, when a coin is biased, now this is something which was not in our IG, that coins and dice and the spinners are not always unbiased. They can be biased. What's the meaning of biased? It means that the die has one number more probable to come. And this is not
Yeah.
like a cheating. It is told to the people. A lot of probability was actually developed in these countries for gambling, for casino development. And this is
Yeah.
one of a very big, huge contribution in their economy, where they offer people, the machines are there, casinos are there. Now they will tell you that, look, in this die, 6 is printed twice. So if 6 is printed twice, then it means that it will be definitely will be more likely to come. This is called biased units. So when they will tell you that this is biased, you have to delete or hold the memory from O level. Why it is necessary to highlight? Because we have a strong memory. For example, in a die, the chance of getting a 6 is 1 upon 6. The chance of getting 6 is 1 upon 6. But if it is biased, if it is not a fair die, then obviously it can't be 1 upon 6. This is a case when you can see here in this question. So that is why I always tell my students in O level and A level that when you read a question, highlight or underline important terms like here, fair die, unbiased die. And once you identify the die is fair or biased, the other work is the same as it was in our O level, that the events which occur together, the probabilities are multiplied, and the events which occur in twice, the probabilities are added. So, acha,
Yes,
then
sir.
another concept was there, non-replacement. For example, a bag contains 3 red and 7 blue balls. A ball is picked, not replaced, and another picked. Complete the tree diagram. So I hope you remember that this is a case of non-replacement. How you
Yeah.
should
Yes,
know
sir,
this?
I remember this part. Yeah. Non-replacement.
So can you orally solve this orally?
Okay, just a second, sir. Okay. 3 red and 3 7. Okay, so I read the probability. Yeah. 3 red and 7 blue balls. Ball is picked, not replaced, and another is picked. So, so here red we will be having is 3 by 10, and blue would be. Wait 1 second, sir. 3 by 10 first pick. I mean, yeah, the 3 by 10, and then 7 by 10 here. And then when we pick it, so it's going to be without replacement.
Hmm.
So we pick that, and then second One second, sir. So then, 2 two by 9, right? Because it's, and then, wait, hold on 1 second, sir. And 7 by 9, and then I hope I'm not mixing it up. Wait, sir. So is it fine? Wait.
I think you're
Yeah.
doing right. The
Yeah.
total will change. That's the main thing you have identified. So that was
Yeah, the
needed.
total will change. 3 by 9. Ah, yeah. That's right. That's right. Because the ball is not being changed.
Acha,
Here it
हाँ.
would be,
Hmm.
here it would be 6 by 9. Yeah. Okay. 6
So
by 9 and then 3 by 9.
when the same
Yeah.
color comes, it's a case of replacement.
Yes, sir. Yeah. Hmm. Yeah, sir. So yeah, it would be 6 by 9 and then 3 by 9 for the last one.
Now, this is a case of non-replacement, and the probabilities are multiplied when events are clubbed. Probability and set language. Now, give this heading in the notes.
Okay, just a second. Probability and set language. Yes, sir. Done.
Now, this is our probability and set language. So when you say A prime, it means not in A. In probability, we used to write the letter A with a bar on it. So n of A prime. N of A prime means that probability of A prime. So it actually means not in A. So this is a symbolic language. So when you say A prime, it means probability that A is not going to occur.
Yeah. A prime. Yes, sir. We learned this concept.
Okay, now you have to copy this.
Just a second, sir. Yes, sir. Done.
A union B is equal to combine A and B. So probability of A union B in set language, it means probability of A or B or both. This is a set language. So you have to copy this.
Yes, sir. Just a second. Yes, sir. Done. I wrote it.
A intersection B means common. This is the language of sets. So
Yeah.
probability of A intersection B is equal to probability of A and B.
Hmm. Yes, sir.
You have to copy this.
Oh, just a moment. Yes, sir, done.
Good. Now, probability of A or B or both. This is a rule. This is again coming from the sets that when examiner says find the probability of A or B or both, probability of A or sorry, probability of A plus probability of B minus probability of A and B. You have to copy this.
All right, sir. Just give me a moment. Yes, sir, done.
Probability of A prime is equal to 1 minus probability of A. A prime means not A.
Mm-hmm. Yes, sir. Yeah. Okay, of course, that will be the rule. Just I read this one as well, sir.
Yes.
Yes, sir, I wrote it.
Mutually exclusive events now coming in set language. When two events are mutually exclusive, the intersection between the sets should be zero. Probability of A union B is equal to probability of A plus probability of B. So this is the case of mutually exclusive events. So actually mutually exclusive already been discussed. It is here in terms of set language. अब ये you have to copy this.
Hmm. Okay, sir. Just a moment. Yes, sir, noted.
Okay, now independent events. What are independent events?
Sir, like they happen. They don't happen at the same time.
No, the
They
independent
happen
events
at the same time.
whose they do not affect each other's probability.
Haha. Yeah. Like
Like their probability does not change. They do not change the probability. For example, a die is thrown no matter how many times. no
Yeah.
matter how many times, it is basically a case of it's a case of independent event. So, for example, you have a coin, you keep on tossing it, it will be 1 upon 2. This is called independent event.
Yeah. Okay. Independent events. Okay. Yes, sir.
So how the formula comes, probability of A intersection B is equal to probability of A into probability of B. This is a very unique formula. It was not there in our IG, that this is a unique formula. So for independent
Hmm.
event, these formulas do not make any sense right now, and they shouldn't, because we haven't discussed them. They have to make a proper sense when we talk about them. When we talk about them in past paper way. So
Yeah.
one,
Uh-huh.
please copy this. Chapter one.
Okay, sir. Just give me a moment.
One thing I had to discuss with you, that this book, you must have this book, na, the chapter one, chapter pure maths, the Excel endorsed book. You have its printed form or digital form?
Sir, I have the digital form right now. The printed one, I'll be getting it next week.
Because schools give it
Yeah,
officially.
they do give it, but there was an issue, so like they'll give it next week on Sunday. But yeah, yes, sir.
So once you are done with the PDF, I have shared with you the past paper PDF. Now, this is a very good book. Actually, people use it and concept wise, but obviously, books have similar questions, so people do not go for it. But this is a very good book, especially the chapter 3, equations and inequalities. So, they have explained very well. This is a portion where this is also a portion where everyone gets stuck. Inequalities means shading part and the shading question. So what I suggest, that once you are done or in between, you should try some questions from the chapter review of this book, chapter review 1, chapter review 2. They have also a section called past exam style question. I'm not sure this is there
Uh-huh.
in this or not.
Okay.
Acha,
Yeah,
then
so what
if
did you say in the end?
hmm, the weakest
Y-
chapter we have, and which is weakest chapter for everyone, is graphs and transformation. This is chapter 4. Now,
Yeah, yes, so chapter 4.
is also a very good chapter. Acha, this book is very helpful. The time is the main issue. This book, obviously being a book, it takes a lot of time. So I'm putting a homework for you, that you should try to do some questions from the review exercises. This is very helpful, and then we can think of putting an online test, so we can see that what are our mistakes. The main problem which A level actually generates is the twist. In book questions, definitely there is no twist. But we tried to do the past paper questions directly, and mashallah, we did all the topics, but this graph topic is not responding. You must have seen that it is not getting perfect. Acha, when this
Yeah,
happens in table in any subject, so what's the root? If a chapter is not getting fixed in any subject of A level, then you have these Edexcel endorsed books. So you should go in the book, and then you can try some questions from there. Second is obviously the online is the Save My Exam. They have very good videos. Now they have so very good notes. Now they have introduced videos also, and they have also introduced flashcards, which are also good. So I'm
yeah,
going to the homework here, and you should try this work. Now, coming back to the topic, we are doing independent events. A intersection B is equal to P of A into P of B. Same formula can be written A and B is equal to P of A into PB.
Hmm.
So now you have to
Oh, yeah,
copy.
yeah. This is intersection. Yeah. Yes, sir. Okay, sir. I'll note them down.
Hmm. The probability that A and B occur is written like this. So, for example, I roll a dice. What is the probability that either the roll is even or prime? We know this thing
Yeah.
already, but what are we doing right now? We are introducing the same concepts in set language. So we know them. So
Yeah.
we show them the event is even or prime. So we show even or prime, and then we show it as a probability function of look, this is the entry. Make it clear that set language is not a parallel language. I mean that you cannot do them together. It's a way to solve probability either with set language or without it. Logic is the same. Now look at this. A union B is equal to P of A plus P of B minus P of A intersection B. So when you put the values here, you will show that you are putting the events, and then you put the probability here. So,
Hmm. Okay.
now look at the working of this.
Hmm. Okay, sir. Just give me a
Now,
minute. Okay.
now what is this example showing? I'm going to post this example that how we apply set language in probability. This is a new thing. Gradually, it will be absorbed. I'm also willing to see that is it coming in this test or not? The whole probability is coming. Actually, they are
Yeah.
following.
Sir, in the school test, right? Yeah, the whole thing is coming. 1 to 4. I mean,
No, but
yeah, probability. Like,
no
wait, let me see.
probability in set language.
Yeah, sir, I think it's there because there was like Venn diagrams and all of that. Then there was independent.
It's a good.
I'm just checking, sir. Just give me a minute. Conditional probability is there. Set language as well. Yeah, they are asking about it. Probability formula.
In pure, there are total 4 chapters from the book, right? Or 5 chapters.
Four. That are coming. Yeah. Yes, sir. I think the entire probability, like set language and all of that is coming.
Hmm. Acha, I'm posting this example. You have to see it better to copy it with understanding after the class.
Okay, sir. Sure, I'll do it.
But first is get copied somehow is speaking unnecessary. I have shared the example. This is an example how set language is how set language is used in how set language is used in probability.
Huh. Yeah, sir. Yeah. Yes, sir. See the example. I have it open as well.
Okay. Now look at this calculation. Now look at this working. You have to
Hmm.
take up the calculator and solve it.
Oh,
Formulas you have
okay. This is.
written.
Huh. Yes, sir. Just a moment.
In statistics, there are also 4 chapters.
Yes, yes, sir. Sir, for the first one, I'm getting 23 over 30.
Look at the formula.
Yeah, I use the same formula.
Now try number.
Yeah.
This is similar. It's similar actually. Now try this. Number 2.
Question 2?
Yes.
Yeah. Okay, sir. Just a moment. Sir, is it 3 over 8 for part, for question 2?
Mhm.
Wait,
I'm
hold up.
getting 7 upon 20.
Wait 1 second. Okay, okay. Yeah, yes, sir, it's fine. I did multiply instead of plus. Yeah, it's 7 over 20, so it's okay. I multiplied it instead, but then yeah, it's okay now.
Okay, now see part number 3. I have shown the
Question 3.
formulas. You have to carefully see the formulas before starting.
Okay, sir. All right. So I'm getting 31 over 56.
31 upon 66.
56, 56.
Hmm.
Yeah, I rearranged it first, yeah. Yes, sir, is the answer correct or?
I'm getting 31 upon 56.
Yeah, yes, sir, that's what I got.
Okay, now independent events. Events are independent if one occurring has no effect on the probability of the other occurring. This is a professional
Yeah.
style definition of independent events. So when events are independent, the formula says probability of A intersection B is equal to probability of A into B. Now, this is the formula. Now, see the example, two events A and B are independent such that P of A is 1 upon 3, P of B is 1 upon 4. Find probability of A intersection B. No need to copy the question, just solve it, part A.
Okay, sir, just a second. Mm, Sir, part is 1 over 12. And then part B. Part part B would be sir, part B would be 1 over 3, right? Because according to the top, like the first formula, P, yeah. And part C, yeah, B is fine. Part C, you just give me a second. So is it 1 by 2 for part C?
Hmm?
Yeah.
That's good. Now try this one.
Okay. P is equal to this. Okay. Show that A and B are independent. Okay, 1 second. So sir, I'm finding PA, what's it called? 1 second, 1 second. A intersection B, so I'm getting 1 over 20. And then, yeah, use this formula. Yeah, yes, sir. So that's what I do, sir. Like, just
Hmm.
simplify, just leave it till here.
No, but we need to find, we have to show that A and B are independent. So we found A intersection B. Now we have to multiply A and B probability to prove that, because when events are independent, what's the formula? When events are independent, remember this formula, when events are independent,
Yeah,
probability of A intersection B is equal to probability of A into probability of B.
yeah, yeah. When we do that, like for 1 over 4 times 1 by 5, so we are getting 1 over 20. So they are independent.
Hmm. Okay, good. Okay, now see this question number 1.
Okay. A, B, B, B. Explain why A and B are not independent. Okay, just give me a moment, sir. Okay, sir. So when we are finding A union B, so we are getting 19 over 30, I believe. But then when you multiply A and B together, so we are getting 1 by 6. So they're not independent here. Because, yeah. Okay, why A and B are independent?
So they are not coming equal?
No, no, they're not coming equal for the first one.
Yes.
That's why
Now,
they're not independent.
yes.
Yeah, just a second, sir. Yes, sir, they are independent. Like first we use the formula, we do P, A divided by B, like 1 by 3 times 3 by 4. Then we get 1 by 4, and then we use we multiply A and B together, and we're getting 1 by 4. So we're getting the same value, which is making it independent.
Is getting the same answer.
Yes.
Okay, good. Now see the third one.
Okay, just a second. Find A. Okay. So is it 13 over 21?
Yes.
Yeah. First I found A intersection B, and then, using the formula, I deduce the values.
Now you have to give the heading mutually exclusive. Practice for
Mutually
that.
exclusive. Okay, I give the heading, right?
Yes.
Okay.
Events are mutually exclusive if they cannot occur together. And A and B are, this is a very important rule which we had written, that events are mutually exclusive. It means A intersection B, the probability of A intersection B is equal to 0. You look at this. You have done it already.
Yeah.
Now, if A is X, B is Y, write an expression for A intersection B when A and B are independent. So now try this.
Okay, so just a second. If A is so wouldn't it be 0 because they're mutually exclusive, the value would be 0?
Hmm? No, no, you have to make an expression. You have
Okay,
to
okay.
make an expression in terms of, you have to make an expression in terms of X and Y. Now, simply multiply
Okay,
them.
so X and Y, we can say X, Y, yeah.
Very good.
Okay, okay, got it. Yes, sir, I wrote it.
Now make an equation for this.
Are mutually exclusive. So now, sir, it would be 0, right? Like x, y equals to 0.
So you make an equation, intersection
Yeah.
0.
Yes, sir. Yep.
Now, complementary probability, it was a language, the word complementary was a language in sets. Complement means it is present, it is not, it is present in the entity set, but not in the given set.
So it's like out of the set, like out of the diagram.
Hmm.
Okay, okay, okay.
Now you have to copy this also in notes.
Okay, sir. Just a moment. Yes, sir, I wrote it.
Okay. P of A prime is equal to 1 minus P of A. So complementary means subtract from 1. Complementary
Yeah.
means subtract from 1. Now
Yeah. Yes, sir.
these are the formulas for these are the formulas used for these are the formulas used for what? These are the formulas used for set language. Let me share it for memory.
Okay, sir. Then maybe after the class, I can just write it at the like last thing, like just a summary to just just a
Mhm.
quick review,
What? Which one?
like
No,
this slide. Like after the class, maybe I can just write it,
uh,
just for a quick review of things and all.
set language is something which actually troubles everyone. This is not, this is after conditional probability, it is the difficult part. The problem of set language is its unusual style. It doesn't fit with many logics. But we have
Mm-hmm.
started it today, and that's why we didn't do it on that day. Now we have given it separately. So this is probability and set language. Now this is a poster for that, and now look
Yes,
at
sir.
this. Look at this question, and the bag B contains 6 balls, which are 3 are red and 3 are yellow. The bag Q contains 7, a long set of data. He says, complete the tree diagram shown below. Now, can you fill it?
Okay, sir. Just give me a second. Okay, 1 second. Do the three. Okay, wait. So yellow. So it's without replacement or with 1 second. Drawn at random from bag P and then placed in bag Q. Okay, 1 second.
Yes.
1 minute, sir. Red and yellow. Yellow. Okay. 3 are red and 3 are yellow. If a red is picked, so yeah, 1 second. Yellow. Yellow would be 2, 5, 5. Mm, Okay, now, okay, third ball is drawn at random. Now it's coming in bag Q. So, red, 5, and... Oh, okay, I got the question. Yeah, this is then bag Q. The 7 balls, 4 are red, and where's the other one? 3 are yellow. One second. Wait, so just give me a moment. Bag Q has this much. But sir, can you explain the second part? Like what I'm, wait, no, because I'm kind of getting confused here. 5, wait, no.
I think we have done too much today. So I think we should stop here because this is fine because already we have done. I think this question is too big to complete today.
Yeah.
So if we recollect ourselves here that there is a set language for all the probability concepts, which includes mutually inclusive conditional probability and independent events. So for all these concepts which are in our course, there is a parallel language of sets. So this language means that you can solve these questions like conditional probability cannot be solved by logical way normally. Normally we need the set language. So set language is helpful there. So if you memorize this summary, I think we are done with the chapter actually. Probability is over, but obviously probability is such a topic that it needs past paper questions and book questions also. So we have done some book questions today. So we can, I think we can start inshallah in our next class. Okay. Thank you.
Okay. Allah Hafiz, sir.